GMAT all day.
One set of keywords that I am always looking out for on the GMAT is the phrase "at least," which comes up a lot in probability questions. And I think a lot of people have been conditioned or have been taught to just think of at least questions. Those are the ones where you do the one minus thing. So to start, let's talk about what that means. If I were to say I'm selecting a bunch of people to be on my committee, and I want to know what is the probability that at least 10 females get selected to the committee. Well, the probability of selecting at least 10 females, that should be equal to 1 minus the probability of not selecting at least 10 females. And so, like a lot of things on the GMAT, just because you can do something or just because something is true, doesn't necessarily mean that you should think of it that way. And like most things, I would say you don't want to be just reflexively doing something without understanding why. And in this case, there will be some cases where it is more efficient to think of at least probabilities in terms of this 1 minus rule. There'll be other times where it is simpler or more efficient just to think of it like you would normally think of probabilities. And so let's look at a question here and see if it makes sense to use our 1 minus rule, or if we should just build our solution from the ground up directly. So this question says, Mikey has 4 questions remaining on a multiple choice test, in which each question has 5 answer choices. In order to receive an A on the test, Mikey must correctly answer at least 3 of the 4 remaining questions. If time constraints force Mikey to guess randomly on the 4 remaining questions, what is the probability he receives an A on the test? So to determine whether or not it makes sense to use our 1 minus rule, let's talk about what at least 3 of the 4 remaining questions really means. And so there are 2 ways you can get at least 3 of the 4 remaining questions. We can find the probability that he gets exactly 3 of the 4 remaining questions. So that would be the probability of 3 questions right. And that really means 3 questions right plus 1 question wrong. Or you can also get all 4 of the questions right. And so if we want to find the probability of getting at least 3 of the 4 questions right, we really can just break that down into we need to find the probability of getting exactly 3 questions right, or the probability of getting all 4 questions right, which would mean you have to find these individual probabilities and then add them together because it is an or scenario. So before we do this though, let's see if maybe we should be using our 1 minus rule instead. And so in this case, what would 1 minus, so in this case it would be, these are example here, the probability of getting at least 3 questions right would be 1 minus the probability of not getting at least 3 questions right, which would really be 1 minus. And so what are all the ways I can not get at least 3 questions? So that would be 1 minus the probability of getting 0 questions right, as well as the probability of getting exactly 1 question right, as well as the probability of getting exactly 2 questions right. And so would I want to use my 1 minus rule here? I would say absolutely not. If we are using our 1 minus rule, we have to calculate 3 things, which is more than we have to calculate here. And then in addition to having to calculate 3 scenarios, we have to keep in mind, we have to remember to then subtract that probability from 1, which we don't have to do here. So in this case, I would say, even though the phrase at least appears in the question, I am not using this 1 minus rule. This makes a lot more sense. And so let's approach our question this way. And let's start with this scenario here, the probability that he gets all 4 of the questions right, because that is always going to be the simpler scenario when all of the outcomes are the same. And we'll see why in a second. So it is a multiple choice test with 5 answer choices, and he is guessing randomly. He should have a 1 out of 5 chance of getting any question right. And so in this case, if we're talking about the probability of getting all 4 questions right, we're talking about getting the first one right, and the second one right, and the third one right, and the fourth one right. So it's just 1/5 times 1/5 times 1/5 times 1/5, which should be 1 over 5 to the 4th, which is 1 over 625. I know my powers of 5 up until 5 to the 4th. Just something worth memorizing. Now let's talk about this scenario here. So the probability of 3 questions right, and we said before, 3 questions right really means 3 right, 1 wrong. So to think about this, we can just draw out an example of how this can happen. So let's say he gets the first 3 right and the last one wrong. For any given question, if he has a 1/5 of guessing right, he has a 4/5 chance of getting it wrong. And so this would be 1/5 times 1/5 times 4/5, which is 4 out of 5 to the 4th. Then, if this is an or scenario here, because he can get 3 right this way or this way, we should be adding these two guys together. And so this would be 4 over 5 to the 4th plus 1 over 5 to the 4th, which is 5 over 5 to the 4th, which is 5 over 625, is 1 over 125, which is answer choice B, but it is also wrong. Not select this. Maybe, or hopefully, you saw why this shouldn't be right. So this here, this is right. Here is where I made a mistake. Because what did I do here? Is this all of the ways he can get 3 questions right? This here, this 4 over 5 to the 4th, this represents the probability of this specific scenario. First one right, second right, third one right, fourth one wrong. But there are other ways that he can get 3 right and 1 wrong, depending on how you move the wrong question around. So you'll get right, right, wrong, right. You can get right, wrong, right, right. Then the final scenario could be wrong, right, right, right. And all of these are going to have a probability of 4 over 5 to the 4th. So really what you have to do here is, once you find this probability, you got to multiply it by 4, because you can move this, it comes down to this wrong answer choice, which can go in any of these spots. So you got to increase the ways you can get 3 right and 1 wrong by a magnitude of 4. So 4 over 5 to the 4th times 4, that should just be 16 over 5 to the 4th. Or you can think about it as, I can get 3 right, 1 wrong, this way, or this way, or this way, or this way. Add these, should get you the same thing. So 16 over 5 to the 4th is what we're adding here. Just cross this whole thing out. Now have 1 over 5 to the 4th plus 16 over 5 to the 4th is equal to 17 over 5 to the 4th, or 17 over 625. And E is actually our answer. So I'm always on the lookout for this keywords here, at least, but it does not mean I'm just blindly plugging into some formula. Now, I don't want to disappoint you, so let's actually do a question in the next video where we actually make use of our 1 minus rule, and we can hopefully see a scenario where it is appropriate to use it.